Hey everyone, Mr. Skelton here. We are back at it, lesson 10 in Unit 4, and today we're going to be talking about, it's kind of hard to read on your notes, but we're going to be talking about the fundamental theorem of algebra, okay? And I know that sounds really crazy and very important. Basically, the fundamental theorem of algebra is all about the number of solutions that we have, okay? And then the type of solutions that we have. And we're going to talk about that in our very first slide. So, when we have a polynomial to the nth degree that has n solutions, what do we mean by that? Well, you already know this, to be honest with you, and when we talk about the fundamental theorem of algebra, you kind of know most of this already, since we've been talking about it all unit. For example, if we have y equals x to the fourth, or 0 equals x to the fourth, or whatever, we said we have a polynomial of degree 4, we're going to have 4 solutions, right? If we have x to the seventh, we know that we're going to have 7 solutions, okay? And so in today's lesson, and so on and so forth, whatever the leading degree is, that's how many solutions we're going to have. And so in today's lesson, what we're going to do is basically look at some questions, and we're going to try to figure out not only the number of solutions, but what type of solutions that we have. And so down here, you can see in this big box here, we have what we call complex solutions, okay? And so complex solutions basically mean real and imaginary together, okay? And so basically what I like to say is it's everything, right? So like this right here where I put x to the fourth, how many solutions does it have? It has 4 solutions. We would say it has 4 complex solutions. This has 7 complex solutions. It's just the total number of solutions. So prior to this lesson, we've been just stating the number 4, 7. X to the fifth has, we would say, has 5 solutions. We're going to get a little bit more technical. We're going to say it has 5 complex. So complex means whatever the highest degree is, that's how many complex solutions there are. Now, that's the first thing. The second thing that we get into is this idea of, and you know this already, we've had some real solutions and we've had some imaginary solutions, right? Our real solutions are rational solutions like 5 or -1/2 or something like that. We've also had some irrational solutions like plus or minus the square root of 2. Imaginary solutions, plus or minus 2i, plus or minus 5 plus or minus 3i, something like that. And you'll notice here that imaginary solutions are always coming in pairs, right? Always coming in pairs. If we have irrationals, those are always going to be pairs because we have the plus or minus, okay? Real solutions, you can have, you could have 1 real solutions. Those don't need to be plus or minus, okay? So let's apply this to a couple questions, and I think this takes a little bit of practice to get the hang of, but I think you'll be okay. So it says, think about this example, and we've got 5 questions here. It says y equals x to the fifth, blah, 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 blah. How many complex solutions are there? Well, we just talked about this, right? So you got x to the fifth, there are going to be 5 complex solutions. Whatever that highest degree is, that's how many complex solutions there are going to be. Now, this is a helpful hint. Let me get so you can see this. When we start talking about how many imaginary, how many real, these are all possible, okay? We don't know for sure, but we're just talking about the possibilities of the number of solutions. So when you think about imaginary, you know that they have plus or minus, they come in pairs. So my little hint to you is always start with the imaginary solutions, okay? I think that's usually helpful, and in the past when I've worked with students, usually start there. So what do I mean by that? Well, let's think. There's 5 total solutions, right? There's 5 complex. How many possible imaginary solutions could there be? Well, there could be 0. We could have 5 real solutions, like 7, 8, 9, 10, 11. 7, 8, 9, 10, 11, 12, right? 5 solutions. We could have 2. There's a possibility of 2 of these 5 being imaginary, right? What if 2 of the 5 were like plus or minus 6? And then 4. Now we can't go past 4. We can't go to 6 because there's only 5 solutions. So we could have 0, we could have 2, we could have 4. Now, the reason I give you this hint here is because once you write down the possible imaginary solutions, they're always going to come in pairs. I always go right from the imaginaries and go right into the reals from there. And so what I mean by that is this. Okay, so play this scenario. If there's 0 imaginaries, then how many reals could there be? There would be 5. If there were 2 imaginary, how many reals would there be? 3. If there were 4 imaginaries, how many reals would there be? 1. If you look, both of these, if you add them up, they're always going to make 5. And so that's why I always say start with the imaginary, because you know those are always going to be even numbers. 0, 2, 4, 6, 8, 10, 12, whatever. Whatever the degree is, you're going to have to start with 0, go to the last even number before you get to the solution, and then just do your reals right from that. Okay? Your rational solutions. Remember our rational solutions, we've done this before. I kind of run out of space a little bit here. Remember our rational root theorem, which was lesson 8. If you forgot lesson 8, you can go back to that. That's where we did our P over Q. So we have to list all the factors of 72, and there's a ton. So that's going to be like plus or minus 1, 2, 3, 4, 6. Kind of going faster in my head here. 8 works, 9 works, 12 works, 18, 24, 36, 72. I may have missed one, but I think I got all those factors of 72 in. All over the leading coefficient, which is 1, so plus or minus 1. Those are our possible rational solutions. Now, part E on this one says solve it, so this is good review. Now, if I was you, hopefully I'd allow you to have the graphing calculator on this one so you didn't have to test all of these. But I'm just going to test the number 2. The reason I'm testing the number 2 is because I know it works. So just to save some time here. So I'm going to test 2, right? 2 is a possible one. And I got a 1, a negative 2, 13, negative 26, 36, and negative 72. And let's see what I got here. That's a 1, that's 2, that's a 0, that's a 0, that's 13, that's 26, that's a 0, that's a 0, 36, and 72, 0. So I know 2 works, right? And it says to solve, so I got solution, so right now I got x equals 2, that's a winner. And then what do I have left? Constant x squared cubed fourth. So this gives me x to the 4th plus 13x squared, is that right? Constant x squared, yep, plus x plus 36. And now, remember, we always want to see if we can factor this. This looks factorable, right? It's 4, 2, so that's going to factor in what 2 numbers multiply together to give you 36. Add together, you get 13, 9, and 4, right? 9 plus 4, 13, 9 times 4, 36. So that's x squared and x squared. Now remember, it says to solve, so we set that equal to 0. So I'm going to kind of shoot over here. I'll have to finish it up in red just to give it a break in color. So this is going to give me x squared plus 4 equals 0, and x squared plus 9 equals 0. X squared equals negative 4, x squared equals negative 9, square root x equals plus or minus 2y, and x equals square root plus or minus 3i. Now, how many solutions did I end up having? I should have 5, right? Let's check. There's 1, 2, 3, 4, 5. So I had 4 imaginary, which I knew I could get, and I had 1 real. There's your real, and there's your imaginaries. Okay? Most of the problems that we do from here on out, we're just going to be answering questions basically A through D. You should already know how to do part E, which is solve, and you've been doing that now for, feels like a couple weeks. All right, so go ahead and hit pause and try these last 2 questions and see how you do. Okay, so it says how many complex solutions there are here for this first example. There are going to be 8 complex because our highest degree is an 8. Imaginary, remember imaginary come in pairs. There could be 0, there could be 2, there could be 4, there could be 6, or there could be 8, right? How many reals? So again, I take my reals right from here. So if there's 0 imaginary, that means there would be 8 real. And then if there's 2 imaginary, that would be 6, and 4, and then 2, and then 0. So those are your possible. Our rational solutions, remember, that's our P over Q. So that's going to be plus or minus 3 and 1, because those are our factors of 3 over factors of 2, plus or minus 2, and 1. Over here, how many complex solutions? There are 7 complex solutions there. How many could be imaginary? Remember, imaginaries come in pairs, so I could have 0, I could have 2, I could have 4, and I could have 6. Can't go to 8 because I only have 7. And then my real solutions come right from here. I always go through this scenario every time in my head. If I had 0 imaginary, how many reals? There would be 7, right? The total's got to be 7. If I had 2 imaginary, that means there'd be 5. If there was 4, there'd have to be 3. And if there were 6, there'd have to be 1. Possible rational solutions, P over Q, that's going to give me plus or minus 5 and 1 over plus or minus 3 and 1. Okay? Once you get the hang of this, it goes pretty quick. And again, this is all dealing with the fundamental theorem of algebra, figuring out the number of solutions and the types of solutions that you have. All right, look forward to answering your questions if you have any in class, and I'll see you then.